All right, thanks, John. So for the hello. Oh, beautiful. All right. For the past 10 years, I've been the CEO of a pharmaceutical company, and it would cost hundreds of thousands of dollars for us to investigate one of our ideas from the patent perspective. Even worse than those costs that we're spending with patent counsel, I was using my most valuable resources, right? My top scientists, and rather than having them spend their time creating new drugs, they were spending their time reading patents, literally thousands of them. This is not a problem for me alone. Last year, approximately $20 billion was spent in the United States on patent-related services, and that insane number doesn't even include the costs of internal use of resources to go after and better understand these opportunities. And so we spent some time this weekend chatting with some experts about what's going on and why this is so resource inefficient. Here on our left, this is Anjali. She's a legend in the medicinal chemistry field. She's got over 70 patents that she's been granted for new medicines. On the right, this is Lorna. She's a partner at a Silicon Valley law firm who has spent decades advising her clients on how to best get patents approved. And so what these folks are doing, first on the scientific side, is teams like Anjali's are searching, right, because she's looking for freedom to operate for these new inventions that she has. She's searching these patent search tools such as PatSnap and chemical access services to figure out whether or not she's got freedom to operate. Now, unfortunately, what these tools do is they return results that aren't necessarily helpful, meaning they list patents that actually are unrelated to the invention, or they miss the patents that are. And so she goes through this cycle of using her team to read through these patents, right, to see whether or not this is a patent that actually is related to her work, and then refine those search terms and go through a loop of this. Okay, after some amount of time, she gets some confidence. Okay, I'm not in a position of infringing on anyone else's patent here. I'm ready to go to the legal team where I'm going to spend a lot more time and resources. Now, what Lorna does is very similar, but she does it at a much higher level. Rather than two different search services, she's using upwards of 7 of these. And you might be wondering why they're using so many different search vendors. And the answer is because each of them returns something different. Okay, the actual results that they produce are not the same patents that the other tools do. A team like Lorna's, a bunch of lawyers, right? We're talking dozens of these folks, again, manually reviewing these patents, looking for whether or not these new inventions can potentially infringe against prior art. Again, now in this case, as they're going through that refined process of going back to the search terms, it was described to me as a dark art, right? And in some cases, these guys will actually hire expert consultants to go through those searches and try to find the most relevant patents. Eventually, they get to a position of sort of understanding that patent landscape and go back to the client, and especially if they found something that might infringe, and say, look, can we possibly adjust this chemical series? Can we make some modifications to your scientific work to see if we can actually go forward with a patent that's going to get approved? Now, you might wonder, why all of this is so complex. And the answer is that these technologies that are being used in these patent search providers are pretty old school. And I also want to be clear in terms of what we're interested in doing. It's not to necessarily replace these patent search providers, but we want to go after this whole business process and replace it as a whole using new technology. And so what we've built is a new set of technology specifically for this problem, which is using LLMs and computer vision to actually understand the context of what's in these patents and use that to convert that into a canonical form. Okay, for those who are not computer scientists in the audience, what a canonical form means, it's a definitive definition of what the claims are in a patent. And the reason that that's important is then we can do very fast indexing and search across a massive corpus of patents to be able to determine what actually is relevant and what's not. So let me show you a few slides to better explain this. What we're looking at here is one of the patents that we processed with our system that we built this weekend. And I'm actually showing you a very limited view. This particular patent is over 330 pages of text. I'm actually only showing you the portions of the patent that are relevant to the claims section. Okay, and so what the system has done, what it's highlighted in this particular patent is the Marcuse structure that describes this particular piece of chemistry, the rules that define that Marcuse structure, and then in the text itself, some qualifications about what they mean and what they don't mean as it pertains to that particular definition. Okay, and this is the thing that a human being would go search for in the patent and then use that to try to figure out whether or not we're infringing against a patent. Once that's identified, the system then converts this into this canonical form that I discussed earlier. And again, the key concept here is this is a form we can then do very fast compute on. I'm sure you weren't all expecting a quiz, but I'm giving you one. Here is our new chemical entity that we just created. And the question is, do we have freedom to operate based on this patent? Okay, and by the way, I've made this really easy for you because I've cut out the 330 pages that are relevant, and I've actually shown you the sections that are. Anyone want to make $1 billion bet on this one? And I'm not being facetious. This is a pharmaceutical product. These products on market make billions of dollars. Okay, if we're infringing somebody's patents, this is going to be, whatever, these law firms that we're standing in here, we're going to do very well for us. It's going to be very, very bad for me, right? So what you would do as an examiner, right, is you get out your pen and paper and you'd sort of work through the description of what this thing is and try to figure out, is this actually something we can proceed with or not? Okay, but our system, of course, does this nearly instantaneously. It converts this piece of chemistry into that canonical form. It does the processing. And then in this case, what it's determining is, nope, we should not proceed with this one. Okay, and it actually explains to us why. It explains to us why in the patent claims, we are not able to move forward with this one. So often, at least, as I explain this to people, people think, oh, you've got a much better search engine, or you've got something that's way more accurate. People aren't going to have to look and read through a bunch of irrelevant patents. They're actually going to focus on the one that's relevant. Like, that's true. Like, it's definitely something that can replace all of these search engines that aren't doing such a very good job. But again, we're very interested in actually replacing this whole business process. Okay, and there's two really cool things we can do. One is speed up that analysis big time. Okay, we can actually focus the attention of the reviewer on the claims, the section in the patent that's actually relevant to what you're trying to figure out. Are you free to operate or not? And also, by highlighting the relevant sections, make it very easy for that examiner, someone's looking at this, to figure out what actually is sort of the explanation of what these claims mean. But by having a system that's this efficient, we can start doing even more exciting things, like actually go and figure out what is the entire chemical space that we have freedom to operate in. And back to what I said at the beginning, where I'm personally spending hundreds of thousands of dollars to look at a single idea, we can go to Anjali and say, forget actually inspecting a single idea. How about a whole series of chemistry? How about, a dozen ideas, 100, 1,000 ideas? Now it's nearly zero cost to figure that out. Okay, and what that does is completely change that business process so you can do wildly different things. The team behind this project, Alex, actually was his idea. He pitched me on this and I loved it. Alex and I are very similar. Alex has been a leading scientist in drug discovery companies, Genesis and Redesign, PhD from Princeton, also worked at Google Brain. Myself, very briefly, 5-time entrepreneur. I don't know on those stats how much portion of that might have been me, but been previously backed by Andreessen, SoftBank. I built a lot of large-scale compute systems. The chances are you've been exposed to, but just didn't even know it. And very pleased to have Mengi on the team as well. Deep learning at NVIDIA, and has done some very impressive work at Carnegie Mellon, Penn, and Stanford, also in the drug discovery space. So what's next for us? So we've been spending our time trying to understand like how we could build an MVP and how we'd go to market. We're very interested and focused in the chemistry space, specifically in therapeutics. It happens to be the largest dollar amount spent on these types of services. And we're going to start interacting with, and it's great there's a bunch of lawyers here because we want to chat with you too, about finding some more people in addition to the one we have, to start co-developing this technology as we work on putting an MVP together. From there, we do want to, and we've already started exploring other verticals where this technology potentially could have a great impact, mechanical, software, other things as well. But ultimately, we think where the potential big opportunity could be is in premium services. And we've had some really good calls over the weekend with folks that look at patent infringement. And so like we can do things like look at every pharmaceutical product that's on market and making money today and go back and go through every single patent that ever exists and figure it out whether or not some other owner, these on product markets which are making billions of dollars, infringe against their patent. Okay, that's stuff we can do like this. So we think that's a potential where some of the bigger opportunities can be. All right, that's my 6-minute spiel or whatever that was, 8 minutes. Happy to take, are we taking questions from the audience? Yeah, okay, happy to take questions from the audience or from Zoom. Yeah, you want to give them the mic? Yeah.
That's amazing. I think it's definitely a nascent space very much needed to bring in AI. So initially, are you looking to be a tool that's going to support an examiner in the process of getting that fast track so you can eliminate a lot of the time it takes and the cost, or you're actually trying to replace the whole examiner itself? Because why do we need someone to get this information and then make a decision? Rather, if I'm the scientist creating it before I even start patenting something, I can first look at before you even start the process. So what's initial immediate next steps you're thinking about?
I got to run backward.
Oh yeah.
No, you can measure.
Oh, all right. Sorry, I will give this to the next one. I'll use this. Okay, so the question is like, who do you think the customer is? And no?
Particularly also product journey. Both.
Okay. Yeah. So I think from the scientist perspective, part of what they're trying to figure out is, especially in these cases, where do I have freedom to operate, right? What are the types of products that I can build that I'm not going to run into trouble in the patent landscape, which is different than from the legal perspective, right? Which is helping that advisory of sort of figuring out whether or not in preparation for applying for patents. You also mentioned, I don't know if you're thinking about the patent examiner from the patent office. That was part of your question. Yeah, that's actually an interesting question we hadn't contemplated before. I don't know whether sort of like the economics of helping the government do a better job on this is not something we want to pursue, but it's certainly something that we could look into. Yeah. Okay. Another question here, and we'll do better on microphone management. Apologies. Yeah. One of these on. This one.
Hi, Munib. So what are the KPIs that you would try to optimize? Is it productivity? If so, how would you kind of balance that between across like billing hours that lawyers typically charge by? If you reduce those, do they get to charge less?
So yeah, so we are not interested in producing a discount service. We're interested in improving productivity. Okay, and so again, rather than looking at one thing, why not look at 1,000 things? And so for us, your question is sort of like, what's the KPI? It is, we'll put it in air quotes, sort of the efficiency or the ability to go after new ideas. I don't know exactly how we're going to quantify that per se. And that's definitely something we've been talking about with some of the lawyers we've been working with, of like, how do we actually measure our productivity of what this thing can do?
Hi, I have a quick question. I'm a patent attorney. So my question is, when I do freedom to operate, I don't look at the claims only. I look at the entire patent. So one question for you is, why you're limiting yourself to just looking at the claims, since really the description itself of the prior art is really what do you really look at when you do freedom to operate?
Yeah, no, that's an excellent point. And so I think what we're showing in this demonstration is specifically for the chemistry, which where we've started things off, and those are fairly well defined. But ultimately, what we're looking for the AI to do is to contemplate and to describe what it is that is patentable, and then use that to figure out whether or not our idea matches that or not.
I'm a recovering patent attorney. Is there any application in terms of like infringement analysis, whether certain technology infringes on certain patents or not?
We would love to chat with you after this. So yeah, that is the one idea which we think there's a lot of future value. We had we all just met, right? We spent 48 hours on this thing. And so it's something we're really trying to better understand, like where we can extract the most value. We're still thinking it through, but we think there's some places that it could work for sure. And we've already discovered there's places where it cannot work for sure. And we'd love to spend time with you and better understand those things. Yeah.
So we have some questions online as well. Let's see, maybe Aparna, maybe you can, if I see your hand up, so if you want to ask your question.
Yeah, I have a quick question. I've been looking at the application of AI in the legal space, and it's very, very promising. And there've been a couple of good exits with Case Text and of course Harvey AI. My question for you is regarding defensibility, and maybe this has to do with your architecture or the corpus that you're using. But how do you differentiate in this area, given that the prior patents are available to everybody to examine as well? So can you talk a little bit about your differentiation now and over the long term?
Yeah, and so I think the way we're thinking about that is really focusing on the customer experience and trying to understand these business processes at their core, and focusing on delivering for those customers, which actually brings a lot of value to them. There's other products and sort of activity in this space that's kind of doing slightly different things. I mean, we've obviously got a very specific case that we're looking at. But over time, what we are very focused on is understanding these processes and using that to drive efficiency.
Great. And I see Chenzi, you have your hand up as well, if you want to ask your question.
Hi. I think patents for like different industries look very different, right? So patent for physical goods is, if you look at the documents, very different than technology patents. So will you build different models for different industries, or will it be customized, or do you think you can do it with the very general models?
It will be customized. I think as we start with chemistry, we're going to learn a lot about how to build the space infrastructure, and then from there, as I was mentioning in that last slide, we're going to use that to figure out not only where the right market opportunity is in different verticals, but also where the technology is going to be its most powerful. Yep.
I'll jump in and add there that I think that is part of the defensibility story as well. There's a lot of domain-specific engineering work you need to do that we needed to do here, for example, to be able to process the particular types of structures and diagrams that you get in chemistry patents, which I think you can't really take on with a totally general purpose solution.